Hello and welcome you all. Friends, before going further, I would like to convey that each of my students is a great personality and can do wonders. Only thing that you lack is self confidence. Have confidence in yourself and you will be successful in your life. This is what I tell to each of my students. Today, I am glad to convey that one of my students who has lost his sight has made it to JEE Main and is getting 121 marks in JEE Mains and would positively qualify for IIT Advance. Not only that he will qualify, I am sure he will get into IIT also. So, when a person without a sight can do that, then why cannot you do it? Once again, you can do wonders provided you are given the right guidance, which now you have. You have difficulties, you write to me, I'll do it for you. So come forward. Now let us go to our next question from JEE Main 2019 evening session of 11th of January. Our next question is, in a process, the temperature and volume of 1 mole of an ideal monatomic gas are varied according to the relation V into capital T equals K, where K is a constant. In this process, the temperature of the gas is increased by delta T. The amount of heat absorbed by the gas is, where capital R is the gas constant. Our choices are 3 by 2 R delta T, 1 by 2 R delta T, 2 K by 3 into delta T, and 1 by 2 K R delta T. Friends, this is an interesting question from thermodynamics and only one choice is correct. Before going further, please press the subscribe button and don't forget to press the bell icon to receive the notification of all my future videos. Let us now solve this question. As I keep mentioning in my theory classes that the only relation that is most relevant in thermodynamics is the first law of thermodynamics, that is delta Q equals delta U plus W. Equation 1, where delta U is the increase in internal energy and is given by delta U equals N into F by 2R delta T, where N is the number of moles of the gas and Fb the degrees of freedom of the gas molecules. And W is the work done by the system and is given by W equals integral from V1 to V2 of P dV. And the addition of delta U and W will give us delta Q, that is the heat absorbed by the system. Let us now apply this important technique to this problem. Here, the increase in internal energy, that is delta U equals N into F by 2R delta T, or delta U equals 1 into 3 by 2 into R delta T, which equals 3 by 2 R delta T, equation 2. Let us now calculate the value of W, the work done by the system. We know W equals integral from V1 to V2 of P dV. Let us now convert both P and V in terms of temperature. For an ideal gas, PV is equal to nRT, or P equals nRT divided by V. Since in this problem n equals 1, therefore P equals RT divided by V, or W equals integral from V1 to V2 of RT divided by V into dV. Since the process obeys V into T equals K, or V equals K divided by T, differentiating both sides, we get dV equals minus of k divided by t square into dt. Substituting these values of v and dv in the above integral, we get w equals minus integral from t to t plus delta t into rt divided by k by t into k dt divided by t square, which on simplification gives me w equals minus integral from t to t plus delta t into r dt, or minus of r delta t. Using equations 1, 2 and 3, we get delta q equals 3 by 2 r delta t minus of r delta t, which becomes equals delta q equals half r delta t. So our answer matches with option 2 out of the 4 given choices, and option 2 therefore is the right answer. Please note, the chapter of thermodynamics in physics is based primarily on the first law of thermodynamics and can very well be done by the technique mentioned above. Please do practice this technique on a number of problems and you will become an expert in this chapter. If you still have difficulties, please write to me and I will answer all your questions so as to make your life comfortable. Do not forget to comment, like and share this video amongst your friends and help me spreading the subject. Visit us again for our next video. Till then, Jai Hind.